This is Unit 7, Video 6, Acids and Bases. So we're looking at acids and bases. Definition of acid you learn early on is something that produces hydrogen ion and water, or H+. That's definitely a valid definition of acid. Base would be something that produces hydroxide and water. We're going to refine that definition down to the Bronsted-Lowry definition, which is really the way in chemistry we define acids and bases. And that is proton donors and proton acceptors. A Bronsted-Lowry acid is a proton donor. A Bronsted-Lowry base is a proton acceptor. So let's look at that. If we have a simple reaction, HCl, reacting with ammonia, okay, then we know hydrochloric acid is an acid. And so we can draw a Lewis structure of this. It'll be pretty simple, look like that. Ammonia is going to, it's actually a trigonopyramidal structure, so it's going to look like this. Well, what happens is the hydrochloric acid, the HCl, donates its proton to the ammonium ion, or to ammonia, and we get the ammonium ion. So we're going to get NH4 plus and Cl minus. NH4 plus now is a tetrahedral ammonium ion. So we just want to make the point here, proton donor, that's going to be our acid. Anything that can donate a proton. And you can say, why is it a proton? Because H has a mass number of 1. It's number 1 on the periodic table. So it has 1 proton, no neutrons, and 1 electron. Well, if it loses that electron to become H+, it's lost the electron, H+ is a proton. So you'll hear the term proton donor, proton acceptor. And that's what our Bronsted-Lowry acid and base is. Now, one important concept in chemistry is what we call conjugate acid-base pairs. And that's going to be any pair of chemicals that differ by H+. So any pair of chemicals that differ by H+. So if we think of HNO3, okay, well, a conjugate acid-base pair for HNO3 is nitrate. So they differ simply by H+, not just H+. So you can see here, if I take the H off, I've got NO3, but because this is plus, that has to be minus, okay? If we have something like CH3NH2, we call this methylamine. Methylamines conjugate acid-base pair, or in this case, the conjugate acid, this is a base, because it has a lone pair on the nitrogen, will be CH3NH3+. So regardless of how complicated the compound is, if the two compounds differ by a single H+, they're a conjugate acid-base pair. The one with the H+ is the conjugate acid. The one without the H+ is the conjugate base.